today, this lesson is called Products and Quotients in Polar Form. All right, in the first example, we are going to find the product of the complex numbers, leave the answer in polar form. So product means what? The answer to the multiplication problem, correct. All right. Well, we can multiply and divide complex numbers fairly quickly when they are in polar form. But to multiply two numbers in polar form, multiply moduli. What is moduli? Yeah, it's plural for modulus. And add the arguments. What's the argument? Theta. All right, so my first complex number, I'm going to call it z sub 1 is equal to 4 open parentheses cosine at 50 degrees plus I times the sine at 50 degrees. And then my second complex number, I'm going to call it z sub 2 is equal to 7 open parentheses cosine at 100 degrees plus I times the sine at 100 degrees. All right, so if I'm multiplying them together, it says to multiply two numbers in polar form, multiply the moduli. So outside the parentheses, I'm going to have 4 times 7. And then it said, and add the modulus. So for the cosine of 50 degrees, and then a cosine of 100 degrees, that's going to be the cosine of 50 degrees plus 100 degrees. Plus I times the sine of 50 degrees plus 100 degrees. And then of course, you're not going to leave it like that. You're going to simplify, right? So that would be 28 times the quantity of cosine at 150 degrees plus I times the sine at 150 degrees. So when I'm multiplying two numbers in two complex numbers in polar form, multiply the moduli, and add the argument. Easy enough, right? So example 2. Our directions again to multiply. And my first complex number, z sub 1 equals 6 times the quantity of cosine at 40 degrees plus I times the sine at 40 degrees. And my second complex number, z sub 2 equals 5 times the quantity of cosine at 20 degrees plus I times the sine at 20 degrees. So I know we could do this in our head without showing our work. However, in my notes, I'm going to show my work. So we're going to multiply the moduli together. So on the outside, we'll have 6 times 5. Inside parentheses, we add the complement. So we have the cosine of 40 plus 20 plus I times the sine of 40 plus 20. So we will be left with 30 times the quantity of the cosine at 60 degrees. Should have put little degree symbols in there. Plus I times the sine at 60 degrees. Now let's just do one in radians because it's got fractions in it. Anybody have questions on example 2? All right, example 3. My first complex number, z sub 1, is 3 times the quantity of cosine of 5 pi divided by 8 plus I times the sine of 5 pi divided by 8. My second complex number, my z sub 2, is 10 is my modulus. And then I have cosine of pi 16ths plus I times the sine of pi 16ths. So if I multiply those together, multiply your modulus. So we have 3 times 10 times the quantity of cosine of 5/8 pi plus pi 16ths plus I times the sine of 5/8 pi plus pi 16ths. All right, so on the outside, we have 30 times cosine of, okay, 5/8 plus 1/16. Let me do that over here on the side. We will have a common denominator of 16. So 1/16 won't change. And then 8 times 2 is 16, so 5 times 2 is 10. 10/16 plus 1/16 is 11/16. So that'll be 11 pi over 16, right? So cosine of 11 pi over 16 plus I times the sine of 11 pi over 16. Y'all good with multiplying? Okay. So now let me show you how to divide complex numbers in polar form. All right. To divide two complex numbers in polar form. Divide the moduli and subtract arguments. Example 4. Find the quotient of the complex numbers. This is going to be the directions for example 4 and 5, okay? I should not put example 4 yet. I'll just do this. Find the quotient of the complex numbers z sub 1 divided by z sub 2 and leave the answer in polar form. Express the argument as an angle between 0 degrees and 360 degrees. Now example 3 or example 4. Okay, so we have z sub 1 is equal to 12 times the quantity of the cosine of 3/4 pi plus I times the sine at 3/4 pi. Z sub 2 is equal to 4 times the quantity of the cosine of pi fourths plus I times the sine of pi fourths. So they said z sub 1 over z sub 2, okay? So z sub 1 divided by z sub 2. So for my moduli, that would be 12 divided by 4 on the outside. If it said z sub 2 divided by z sub 1, that'd be 4 divided by 12. That's a difference. Be careful about that. Times the quantity of the cosine of, we're subtracting. So you subtract your numerators argument or your numerators argument minus the denominators argument. Okay, so z sub 1's our numerator. So 3/4 minus pi, 3/4 pi minus pi fourths. Plus I times the sine of 3/4 pi minus pi fourths. Okay, well, 12 divided by 4 is 3 times the cosine of 3/4 minus 1/4 is 2/4, which is a half pi. So pi halves plus I times the sine of pi halves. Now the direction said express the argument as an angle between 0 and 360 degrees. Well, is pi halves as a degree? Wouldn't that be 180 divided by 2 is 90 degrees? Is 90 degrees between 0 and 360? Yeah, so we're good. And when we added it, it didn't tell us that. It didn't like give us a specific way to leave it, but this time it did. So it's okay that it's in radians. Just wanted to make sure in degree form that would be between 0 and 360 degrees. So that's my answer. Example 5. We have z sub 1 is equal to cosine of 80 degrees plus I times the sine at 80 degrees. And z sub 2 equals the cosine at 200 degrees plus I times the sine at 200 degrees. Yeah, so if there's no modulus, what number would be out there that they wouldn't write? A 1, right? Not a 0, but a 1. So on the outside, 1 divided by 1 is 1. Do I need to put that outside the parentheses? No, you can if you want. Let's just put it, and then when we clean it up, we won't put it there. Okay, 1 divided by 1, we don't need that. And then parentheses, the cosine. Now look, it's 80 minus 200, not 200 minus 80, just because 200 is bigger. Z sub 1's in the numerator. It's the numerator minus the denominator. Plus I times the sine of 80 degrees minus 200 degrees. So we don't need that 1 outside. So we have the cosine of 80 minus 200 is negative 120 degrees. Plus I times the sine of negative 120 degrees. Have I expressed my argument as an angle between 0 and 360 degrees? No, it's negative 120 degrees. We need it to be a positive angle between 0 and 360, but we don't want to move its location, okay? So what do you think we could do so that it's the angles in the same place, but it's going to be between 0 and 360? Okay, so it's at negative 120. So that means we're going clockwise, right? 0, negative 90. This is negative 180. So it's about somewhere over here. We want it to be in that same spot. Well, what if I add 360 degrees to it? If I add 360, won't it come right back around to the same spot? It'll be in the same place, right? So if we do negative 120 degrees plus 360 degrees, we get 240 degrees. Would that 240 be in the same place as negative 120? Yeah, so they're in the same spot. So I would express my answer as the cosine at 240 degrees plus I times the sine at 240 degrees. I wouldn't want to subtract 360 because that's going to make me go negative. But if I add 360, that is going to be in the same place, but between 0 and 360. So let's make a note about that, okay? So when you're looking back, like, why did we do that? Oh, yeah. We're going to write it over here in the corner. The directions is going to be tiny, so listen to what I'm saying. The directions said to express the argument between 0 degrees, and 360 degrees. So we added 360 degrees. So the angle would be in the same position. Like I said, I know that's tiny, so I'll reread it in case you missed something. The directions said to express the argument between 0 degrees and 360 degrees. So we added 360 degrees, so the angle would be in the same position and around on a room, but I would have said, and also between 0 and 360 degrees. Coolio. And that is that.